Thanks for joining here, everybody, today for our oboe training at Obo-Academy. Today we're going to have a talk from Chris Mungle of the Lawrence Berkeley National Laboratory on AI-assisted ontology editing workflows. If you're working in the oboe space, I'm sure you're already familiar with Chris's massive contributions to the space. But I think what's changing now in much of ontology curation is kind of the application of these more automated methods, including with large language models, something that Chris has been very interested in pursuing in quite a bit more detail lately, and that's what we're going to hear from him about today. So yes, Chris has also posted a link here in the chat. And yeah, I'd say go ahead and thank you, Chris, and please take it from there.
All right. Thank you, Harry. Yep, I dropped the link there if people want to follow along. This is going to be maybe a little bit experimental and interactive. So I'm going to be talking about mostly demoing some example AI-guided ontology curation workflows. So the goals today are really just to demonstrate some of the things that can be done using the standard generic ChatGPT interface and similar interfaces on other AIs and models that exist out there. What we're not going to be doing today is talking about some of the specialized tools that we have been developed that are aimed to help you with kind of like workflows, and this includes OntoGPT, CurateGPT. There's now plugins for the LLM plugins for the Oak tool. We're not going to be doing any of that today. The goal is really just to kind of help give you a sense of what can be done just with the standard tools that exist out there already, with maybe a slight kind of like patina of kind of like some specialized plugins. If you want to follow along, here's the link. It's a bit.ly link. It's also in the chat. Please just type your questions into the chat. Nico or Harry will interrupt me, and which is great, which is all completely fine. You know, the idea here is to be quite interactive. And I hope this makes you feel empowered to maybe kind of experiment a bit more and explore for yourself. One of the resounding messages that I try and give here is that this is all a very new space, and none of us really know exactly how it's going to play out. So it really helps if we all, if we kind of build up a little community of practice here around oboe and share our kind of experiences. Maybe we can even like write this up later as a group. Then if we've got time, maybe I'll do a brief report on some evaluation we did on some AI methods for generating ontology terms. So a couple of caveats before we get started. The first is AI is weird and non-predictable and non-deterministic. Everything I'm going to show you today, it's worked in the past, and it works differently each time, but it generally works. But all this stuff is non-deterministic. It's quite possible things will just not go as planned, and we'll get back weird answers that don't make any sense. So yeah, but I think this is an experiment, and that's this is part of the reality of using those tools. So even if this does happen, I think it could be instructive. And then the other caveat, which is really, to be honest, a little bit problematic at the moment, is that these tools are not open to all. I'm going to encourage you to follow along, but I don't want to be the salesperson for these companies and say you must buy kind of subscriptions. But the fact of the matter is that if you really want to derive the most from the web-based version of these tools, then it kind of makes sense to kind of subscribe to the higher tiers that essentially give you better models. Now, if you don't want to do that, that's completely fine, and you should also be aware that open models are getting better. I could have maybe tried to do some demos using some of this kind of standard web UIs on some of these open models. but um, but they're not quite there yet. And but the open models are catching up. And when we go to talk about some of the kind of the specialized tools that we've been developing, these will hopefully empower you to kind of like bypass some of this. But at the moment, for using the plain standard web interfaces for these tools, unfortunately, they're not all free. So we'll maybe look a few different ones today. So the one most people are familiar with is ChatGPT, of course. You can use this for free, but if you want to use the better GPT-4 model, then unfortunately that requires a subscription. Um, and GPT-4 is often regarded to be for most tasks the best, although others are catching up. See, I don't know if we'll get to Gemini today. This is the Google one again. They offer a premium account that gives you better models and so on. Um, there's something I use a lot called Claude. This is not so well known. Um, the nice feature about Claude is that it allows very large inputs, something that's historically not been a strength of the other models, although they are catching up. And again, unfortunately, the best model there, Claude 3 Opus, which was actually just released, I think, yesterday, and is gathering a lot of attention, also requires a subscription. Now, there's a newer player on the field here called Grok, Groq, not to be confused with Twitter's Grok with a K. I'm not going to ask you to use that one. I don't use that one. I'm not particularly interested in it. So Grok is interesting because it's a web interface on top of some existing open models like Llama and Mixtral. But what they do is they run these on specialized hardware that goes incredibly fast. Um, and what is also nice is, right for now anyway, they're offering kind of like free access, both API on the web UI. The UI is a bit clunky compared to the others. Um, and as more people use it, maybe it slows down a bit. But I definitely encourage you all to kind of like try this one out as well. And we'll be doing a few experiments with this one today. So with that, let's move on and get started, unless there's any initial questions so far. Um, all right, so some experiments that we're going to be doing today are we're just going to be trying just the main chat interface. Then we're going to try some what I call review-based workflows, then enhancement workflows. Then we're going to look at something called the robot helper, and then another plugin called consensus, which can be useful for finding references. And again, this is all stuff available. Just no, you don't need any kind of like technical expertise. You don't need to download anything and run it on the command line. You don't need to start your own server here for any of these. In later sessions, we'll talk about some more specialized tools. But for now, this is just fairly standard ones. All right, so just to get us started, here's a little experiment. And sorry, I'm going to be switching between kind of like slide mode and demo mode. So something you've probably all tried, but let's kind of like give it a go anyway, is what happens if you just go into a kind of plain ChatGPT interface and start asking it for ontology terms. A lot of people have tried this so far. We're going to ask for terms in obo format just because they're a bit more kind of concise and easy to read. So let's try create a term in the plant ontology for the concept fine root carbon to leaf carbon ratio. Show this in obo format. We've actually been talking about ratios a lot in our phenotype trait ontology, relational ontology kind of working groups recently, so this is quite relevant. So of course ChatGPT gives you, as usual, very verbose, kind of like prelude to anything it does, but then it starts giving us a nice little kind of like a little obo stanza that could, in theory, if your source for your ontology is in obo format, you could just drop this in with a text editor. And on first inspection, this looks not terrible. The definition seems kind of like reasonable. Let's put a little POC your name here because it's inferred. That's generally how references are done in the plant ontology. Of course, we are moving to orchids, everywhere else in obo. But if you look in a bit more detail, this is not really quite right. This is not does not conform to our design patterns. The roots and the leaves are not part of the trait itself. So it's not doing maybe a fantastic job here if we look in a bit more detail. So yeah, but maybe there's other ways we can interact with it, and do things that allow us to work with like terms in bulk. So yeah, just to demonstrate, they give slightly different answers every time. Here's a previous attempt where I tried this, where it at least tried to kind of like make this a ratio between two traits, but in this particular case, it was essentially inventing kind of like IDs. So you want to be very careful here, because anytime you ask ChatGPT for an ID, it's quite likely it's going to hallucinate these. But thankfully, we have a way of communicating ontologies that is actually quite nice to read for humans. It's still computable. And it turns out the things that are quite nice to read for humans are actually quite nice to read for AIs as well. And that is robot template CSVs. And so here's an example. Robot template CSVs for specimens, and this is taken directly from a set of robot templates that are used as part of the obo-ontology. And so I'm going to assume some broad familiarity with robot for this audience, but there's some nice tutorials in this series if people want to go back and look at these. But the basic idea is that every row in your spreadsheet is an ontology term, and then the columns define different properties of that ontology term. So let's talk a bit about review-based workflows. And the basic idea here is that even though AI can be unreliable, it can be useful to have a second set of eyes on your ontologies. It's, as we all know, ontologies unfortunately contain mistakes. It's easy for these to slip through, and it can, even if you have a kind of thorough QC procedure where you look over all the terms that are made, it's still kind of quite easy for some of these mistakes to slip through. So the basic idea is to have the AI review a collection of ontology terms. We're going to represent those collection of ontology terms as a robot template CSV. And just to make it more interesting, we're going to introduce a deliberate error here. So people want to kind of like follow along. Maybe we even want to have a little competition, see who can find this error kind of like faster than the AI. So if you're following along with the links, you can get the gist here. You can kind of like download it. I can show you it here. Maybe you're like you've got laser sharp eyes and you can immediately see what the problem is here. But maybe not, because it's very easy for these things to just slip through. So let's go ahead and, well, actually first I'm going to show you what not to do here. So you might say, okay, I'm going to upload this this CSV into ChatGPT, and have it we're going to ask it maybe are there now what happens if you upload it as a CSV is that it will actually go off and it will write itself a little program to parse that, and it will write some code to analyze that. Now this is quite a useful piece of functionality, but it's not actually exactly what we want it to do today. So but anyway, let's see what happens when we do this. So it's and I don't know if it's hallucinating here. Did I upload the right CSV? I don't think this one has anything to do with units. So, but either, but let's kind of like, let's proceed, maybe come back to that. And the best way to get ChatGPT to kind of like analyze something like this is literally if you just kind of like take the CSV and you kind of like paste it in directly. So we're going to say look, maybe give it a bit of context. And then you can just really kind of like paste it in. It looks kind of ugly, but it's actually doing it this way. It bypasses its desire to write a Python program to parse this, and it will just kind of like look at this, the same way in which a human reviewer might just kind of like look over a spreadsheet. So ChatGPT in its typical verbose fashion will kind of like give you a kind of broad summary of what it's seeing in here. So it's telling me that the definitions appear consistent. And here this is interesting. Number 3, potential typographical error. The definition mentions rabbit MHC class 1 protein complex instead of pig MHC class 1 protein complex as suggested by the RDFS label. That is indeed the error. Did anyone catch that before we got to it with, did anyone download and have a look? All right. So
We do have a question,
yeah.
Chris, from
Sure, go ahead.
Leela here that can we use the instruction in the configure section of GPT-4 and then upload the CSV?
You certainly can. I tend not to use the configuration option myself that much because I like to have this kind of like work in as consistent a way as possible. But we'll get to some advanced configuration later on when we show the robot template. But yeah, no, I definitely encourage you to play with that. So. So anyway, so I think this was successful in this case. It gave us a largely correct summary of what it saw in the table, and it noticed the deliberate error that we introduced here. So that's all well and good, but this was like one of the smaller set of templates for OB. There was only like 30 or so lines in there. Okay, here's one I ran earlier, and it tends to consistently find this issue. Of course, it would be very interesting to do this systematically and have an actual evaluation here where we have a benchmark set with kind of like some deliberate mistakes or kind of like things that are be not quite right, and just run this through programmatically multiple times and see how often it spots this, because I think if we want to incorporate this as part of our workflow, we need to have a kind of like a sense of how reliable it is. But even with imperfect reliability, it can help to have, as I say, an extra set of eyes looking over some of what you're doing if it can be incorporated into your workflow easily. Okay, so that works. Seems to work fairly well for some of our robot templates. But once we start getting into slightly larger ones, like here's, oh, sorry, that's the raw view here. But yeah, this is you can find this in the spreadsheet. But this is a slightly larger one. This one's got over 100 terms in it, and there's quite a few different rows in here. If we were to try and just paste this into the Chat GPT UI, it would like cut us off because there's just too much text in here. So this is where it can be useful to try and play with some other UIs out there, or some other AIs. So I'm going to show you the same kind of idea with this in something called Claude. So Claude is well known for having a larger what's called context window. So you essentially kind of like have bigger prompts. And I personally have found Claude to be quite useful when working with large CSVs, even up to kind of like, thousands of rows. So let's try the same workflow again using Claude. This time I'm going to use just the raw CSV from a different CSV from Obi biobank specimens. I'm not going to use a modified version with a deliberate error or anything like that. I'm just going to use it, the one that exists right now in the Obi repo. And I'm just going to paste this right in, but I'm going to say and I put that in my paste buffer. It's got a nice little UI feature where it will tell you if you've kind of like pasted something in. And you can also upload it. Unlike ChatGPT, it will not try and write a program to analyze it. It will just analyze it directly. So let's see how well this works. So I'm asking it if there's any issues in the attached robot template from Obi in content of definitions or labels or axioms. And yep, like many of these AIs, the responsivity can be a little bit laggy at times, but normally it's done something by now. Okay, yeah, Claude's, I guess because Claude is gathering a lot of interest right now, maybe it's running a little bit slower, but okay, this is not too bad. So again, I didn't introduce any deliberate errors here. So it's telling me that some of these are missing definitions. It's telling me it doesn't like the definitions, even though this is the way we define a lot of compositional terms in Obo, is that they're maybe somewhat kind of like trivially compositional, but telling us that we would like us to write a more descriptive definition. I think some curators would probably agree with it there. All right, so it's kind of like given us, maybe I would argue, maybe not particularly kind of like useful feedback on this one. I'm wondering if I actually pasted the right one in here. In any case, so just this is part of the part of how this works. That it will give us slightly different or information each time. I ran this previously, and it actually, well, let's keep kind of prompting it and say it can often help to be kind of quite specific with these tools. So one of my kind of like favorite things with ontologies when I'm asking humans to review things is I always say, do the labels match up with the textual definitions? This I find to be a kind of like, a common issue with ontologies, that either the labels don't match the textual definitions quite right, or perhaps the textual definitions don't match the logical definitions. Let's see, so a few minor inconsistencies between labels and definitions. So it's one term has the label esophagus muscularis mucosa specimen, but the definition says esophagus muscularis mucosa. I would argue that this is not really particularly problematic. Um, well, just goes to show, you can't always rely on these tools to give you the same answer each time. I ran this previously, and it did in fact catch, a lot of typos with this. So there was kind of typos like cerebrospinal fluid specimen. Um, I always personally misspell vitreous humor as well, but yeah, environmental as well. And then I also previously noted kind of like some inconsistencies between labels and the definitions, where maybe the label or the definition was a little bit more committed than the other would lead you to believe. So in some cases, there was labels that said these were specifically swab specimens, but the definition didn't really say anything that it necessarily had to be collected via swab rather than some other mechanism. I'm just wondering if I pasted in um, the right one here. Okay, well, in any case, that's the results for this one. So let's try another test this time. Here we're going to try what I call an enhancement workflow. So the idea here is that you have part of your ontology again defined. Maybe you have columns with values, for some rows or maybe even for all of the rows. So we're going to use, again, this is a kind of a slightly altered example where I took the biobank specimens from OB and I basically just kind of like removed the definitions from half of them. And again, this is maybe a somewhat trivial example because these are largely compositional definitions, although not all of them are. But yeah, it's still useful to try this as a test. So in this particular case, we're going to try this using this new grok tool. So again, just going to grab everything in as text here, and then I'm going to go over to grok, and I'm going to ask it, yeah, fill in. And if you've used some of these tools before, you might be kind of quite amazed at how fast this is in comparison. Um, and it's essentially given me a new CSV, or annoyingly not quite CSV format, but kind of close enough with all of the definitions filled in. So this was maybe an easy test again because it's very compositional in nature. But in theory, I could take these and kind of like paste it back into my my original one. So sorry, this is what I fed it, and here's all the missing definitions. So a spleen specimen, unsurprisingly, is a specimen that is derived from the spleen, and so on. I think there's an open debate. There's a valid debate in OBO about how much kind of like additional information we give in some of these compositional definitions. In the gene ontology, the curators like to have definitions of the atomic terms included as part of the gloss of the definition, and it will do a reasonable job at things like that as well if we essentially prompt it to do that. So, and oh yeah, so I did this using this Mixtral model. So Grok gives you access to two open models, Llama or Mixtral. Mixtral is a fairly good model. It still doesn't quite do things as well as GPT-4. It's a bit harder to kind of like coerce it to give you back things in the format that you want, like a CSV, for example. But it will it is an open model, and you can run it, yeah, using this very fast hardware, using this Grok interface here. So the UI is a little bit clunkier here, but this is quite a useful one to try. All right. Any more questions so far? Or
Yeah, so Chris, I have one question.
yeah.
So one task that is sometimes now coming up is to see whether we can, harm like extract some kind of like a global idea of how definitions and labels and so on should be represented consistently, and then have something like an LLM look through the ontology and see whether the definitions are after some kind of criteria sort of consistent in some sense. So let's say we have I don't know these assay terms, but they look very, very regular in this case. But
Yes. Hmm.
do you have a feeling of whether the LLMs are somehow already able to, if you feed them, let's say a bunch of definitions, a bunch of labels, and you just ask them, please, can you suggest corrections to those labels in such a way that they become more consistent with each other, so that can it sort of understand that there are regularities in the majority of an input and apply this to everything in the set?
Um, absolutely, yes, yeah. They this is like, I think, one of the strengths of using them. So the basic idea here is maybe you've got some definitions that have been kind of like authored by different people, and they have different styles, and you maybe want to kind of like make everything consistent. Is what that one use case that you're
Exactly, that's
asking?
right. That's exactly the run, yeah.
Yeah, yeah. So we could even, like, maybe try that. So if we go back to kind of Claude here, and what I'm going to do just very kind of like quickly is let's let's just say I don't, maybe one kind of like test is that, let's just say this saliva specimen one was written by someone else, like well, let's make typos as well. Let's see, let's just put something very silly there. Um, um, and let's just take the ones that already have definitions, and let's see. You can also, if you like, just specify your own style rules here. So, you could say make the definitions very concise and sparse, or you could say kind of like make these um, more descriptive. So I think the one that we tried here was yeah, saliva specimen. So indeed, it did rewrite this one to be more consistent. This is maybe less useful here because it's leaving us to do the diff itself. But yeah, this just gives you a kind of like an idea here. I would tend to kind of like trust slightly less, complete rewrites like this. But I feel if you kind of like prompt it instead and say, yeah. Just the idea is to kind of like, try and ask it for a second opinion. So here, yeah, so I had to kind of like prompt it a little bit, but it told me something that, I conceivably could have overlooked, which was this very deliberately odd saliva specimen definition here. So it's told me that it changed it to this, making it more consistent with other specimens in the list. Just for fun, we can try, like, let's say, And really, a lot of the value in these tools is not just throwing something over the wall at them and asking them to do something, but really, interacting with them a little bit more and just, you know, essentially trying to have a kind of like a conversation with it and trying to get it to kind of like, do things in a particular way. So in this particular case, it's maybe being a little bit too descriptive here, but yeah, this is probably not something I would put into, yeah, well, some of them are okay, I guess, but yeah. So amniotic fluid specimen, a biospecimen consisting of fluid that surrounds and protects the developing fetus in the uterus. So many ontologies actually quite like having definitions like this here. Um, Personally, I'm not so keen on repeating the definition of the atomic term here, because it means if this changes in Uberon or wherever, then it has to kind of like change in the downstream ontologies. Although with these kinds of tools, it makes it easier to do these kinds of things. But I think a lot of curators prefer seeing something that is maybe a little bit more descriptive like this. The point is that we can, this gives us kind of like, more ways to kind of like experiment with doing this kind of thing and doing it en masse.
Can I ask another quick
Sure.
one? So for without using anything like Curate GPT or anything like that, so what's the state now of these, like, let's say, more or less out of the box models to be able to also ask it for some level of provenance? Let's say I mean, for the assays, it may be not so relevant, but
Yeah.
let's say we are defining something like phenotypes or diseases. Can we somehow get it to provide us with some references already? Is this something that we can already do out of the box, or do we still need special tooling for this?
Um, I will come to that shortly, but we'll try something now just to show what doesn't work. And let's okay, let's add a column. This is an example of something that you should not do. But let's see what it does. And I've tried this kind of thing in ChatGPT, but not in Claude. All right, it's pausing to think. Come on, Claude. You can do it. Just to note here, it has actually figured out the correct robot syntax kind of here, although we might prefer an Iowa term here. And it's given us some NCPI books. Let's yes, completely irrelevant. Or is it? I think this was completely irrelevant to the one I clicked on. This is body mass index, and that was for oh, I lost what I was doing. But yes, the point is, if you just ask out the box, it will hallucinate things like IDs. But we'll return to this shortly with something that works a little bit better. So okay, so far we've done things that have been completely out of the box with some of these tools. We're going to stay within this theme, but we're going to start. We're going to look at a little plugin that exists for ChatGPT. It's actually very, very easy to write these kinds of plugins. You don't need any programming knowledge at all, and in fact, the AI will help you write these plugins. But we won't cover that today, but we'll cover usage of one of these. So this is a plugin called the Robot Template Helper. This is really not so different from what I showed you already with some robot templates. It's just got a few built-in kind of instructions that help guide ChatGPT as to the structure of a robot template. So like many of these kind of built-in GPTs, it's got you a little set of prompt questions to get you started. And sure, let's try this one. Make an ontology of cell types in the immune system. And hello, okay, here we go. So it's running off, getting started. It can be a little bit kind of like, you know, kind of like flaky. What it starts off doing is it searches its own what's called knowledge base. So I've given this GPT plugin a knowledge base that is essentially the markdown documentation for a robot. So it kind of consulted that, and it went off, gives you its usual kind of like blurb here, telling you what it's going to do, thinking aloud, and then it goes off and makes a little robot template here. And in fact, this is kind of like not this is using the correct syntax. So if you recall, with robot, there's the first row is the human readable columns that you can call these whatever you like. This is a very minimal example: ID, name, parent, definition. And then the second row is something that, you know, many of us probably have not memorized how to do, so it's useful to have an assistant do this for us, and it's done this in the correct way. It's saying the second column is a label, the one after that is a subclass axiom, the one after this is an definition axiom annotation, and it's kind of given us a little mini ontology here. We can go ahead and kind of like just yeah, make a little ontology for this. What it won't do, that I would like to add at some point in the future, is these GPTs have the ability to talk to APIs. So it wouldn't be so hard if there was a robot service that existed already, such that you could just then go turn this into an OWL file and run it through a reasoning service, or run it through the Obo dashboard or something like that. That doesn't exist yet. So right now, if you do want to use this, you have to do something like copy. Before I do this, I'm actually going to ask for a minor modification. Make all the IDs CL IDs. Okay, these terms exist in the CL, but let's pretend they don't. Using my ID range, which is CL. This is not really my ID range, but just for fun, let's see what happens if I ask it for this. And it will renumber. Now, you know, as I said before, you should not trust ChatGPT to look up existing IDs for you, but incrementally adding IDs within a range is well within its capabilities. So, all right, it's made a little kind of ontology here. Let's see what happens if I move over to the command line. Let's just call this save this in a CSV file. Apologies for my weird little command line habits here. I'm just looking up something I did previously, because we're gonna just do test CSV. Okay, so yeah, many of you are familiar with running robot on the command line. Which normally you might do through your ODK Docker container. I just ran it kind of like straight out of the box here. Let's look at this in Protege, and yeah, it actually, yeah, it worked. Now this is obviously a very simple kind of like trivial, you know, high level view of cell types. This would not pass muster for CL, but the point is you can carry on kind of like interacting with it here. You can say maybe add a synonym column. Yes, always telling us what it's going to do. So what's nice here is that it will usually do the right header syntax. Yeah, there we go. This is the magic robot syntax here for doing kind of synonyms, using the obo and al way of doing synonyms anyway. So we can see it's given us no, it may need some tweaking to get the right kind of like multi-valued syntax here, but yeah, it's doing a reasonable job here of keeping synonyms. Anyway, let's try something a little bit more advanced here. What we're going to do next is we're going to take, let's just say that we're very lazy. We've got a figure in a paper and we want to make an ontology for it. So here's just a figure of the kind of like early developmental structures. So I'm going to just take a screenshot of this. I'm going to start a just a new session here. I'm going to say paste this in. Now, occasionally it will try and be clever and it will try and write a program that will use optical character recognition or something like that to parse the figure. So sometimes you know, the trick with these language models is you have to kind of like coax it a little bit and sometimes to say, no, you're actually, you can actually read this, you can read this figure directly without writing a program to do it. But in this case, it's gone ahead and done this directly. It's using this kind of like multimodal kind of feature of GPT-4, GPT-4V it's sometimes called, and it's basically kind of like read all the boxes and read all the arrows. This kind of thing is, I think, super useful for this kind of figure, for kind of like pathway figures and so on. And you can see it's actually doing a reasonable job. It's choosing to represent, develop, this in the opposite direction I would derives into. We typically do develops from in ontologies, but it's also chosen to represent this as an annotation rather than a logical definition. But we can, it doesn't matter if it doesn't get it quite right the first time around. We can kind of like we can just ask it to reverse the order of developmental relationships. Just while it's kind of like thinking about this, feel free to jump in with any
Chris,
questions.
Trish has a question about specifically for images. Have you tried it with a UMLL pardon me, my sister has escaped in my office. Or sorry, hey. Have you tried it with UML diagrams to generate DDL?
Absolutely, yeah. And I don't have time for it today, but there is another helper called the LinkML schema helper. And it is designed not to make ontologies, but to make DDL and schemas and so on. And in fact, one of the things it's quite good at is taking figures, whether it's formal UML or even just a whiteboard diagram of here's my schema and kind of translating that. So, and so, okay, so it successfully reversed this, and it actually figured out that it needs to make this a logical axiom and not an annotation axiom here. So it's it's done the right thing. This is quite minimal. We can just go ahead, ask it for definitions and so on. But just in the interest of time, maybe let's just kind of switch track a little bit and show a different plugin. Now you can actually summon some of these plugins directly in the UI. Again, unfortunately, you need the subscription option, but I'm going to show you a plugin called Consensus. If you've used a tool called Perplexity, this is quite similar, but it's much more integrated in to your ChatGPT experience here. So I'm going to switch from the robot template helper to the consensus helper, and I'm going to ask it for, maybe what are some marker genes for the, let's say, let's find one. Let's do the paraxial mesoderm. So what is great about consensus is that it will do a search of the literature. I'm guessing they have kind of like done a giant vector embedding of all of PubMed, and it will essentially do a combination of search and retrieval, and then kind of like using the large language model to synthesize some of those results together. So we're now getting all of the different marker genes for the paraxial mesoderm. And again, I wouldn't necessarily, trust these directly. But what is nice here is that it's giving you references, and these are not hallucinated references. The reference may not say exactly what it's saying here, but you can be sure it's this is a reference that talks about Wnt3a and the paraxial mesoderm formation. So and I can prove that for you. So let's click on this first one here. That's moving. Let's see. This is we're on the consensus app here. This is its own summary of the paper here. So, but you can always go directly to the full text. And yep, here we go. It is indeed very relevant. So even if you don't necessarily trust its interpretation of these papers, this I find can be just a very good, advanced literature search feature that can give you a heads up here. And I think with that, with 5 minutes to go, this is a good point to just kind of like stop and have a discussion, see if there's any questions remaining. Maybe I'll stop sharing here.
We do have one question from Nico about whether the LinkML schema helper works for OWL as well, and how that relates to Schema Automator.
If the use case is taking an OWL ontology and turning into a schema, first of all, there's all the kind of usual caveats that apply there. That OWL is not an ideal schema language, but some people have used OWL to make schemas. I have not actually tried that, and I would just use Schema Automator there. I think it's the main reason to use something like this is to take it from something that is not already formally precisely specified, but is something like rough, like a semi-textual description, and then translate it.
Okay.
Thanks.
Along, I guess, vaguely similar lines as well, how feasible is an approach kind of like the robot template approach for building system?
You could adapt the overall approach, but I think implicit in that use case is doing the matching itself, which I think is a whole other topic for another one of these. So because SESM is less about organizing knowledge, and it's more about just representing the mappings with the provenance. So I sense it's not without the addition, if you can plug it into additional tooling that is good at doing the mapping. And again, the review workflow works really well for SESM. So you can give it, I found this anyway, you can give it a SESM file and it can have maybe some lexical matches, but it can maybe, with the right kind of prompting, it can tell you, oh, it looks like you've made these things exact matches, but in actual fact, these are really, subtly different concepts, or this one's narrower than this. So again, as a kind of like a second pair of eyes over your CSV files, I think it can be very useful for review.
Right, that makes sense. All right. Do we have any further questions, comments, concerns?
Jim had another question.
Oh, yes. We have, Jim mentions these examples have had all sorts of quirks and caveats, as promised. Is it possible that fine-tuning targeted to these use cases could make it more reliable?
Quite possibly, yeah. Yeah, I at the end of the day, that I don't think the fine tuning will solve this, just the general quirkiness that, you know, it's somewhat indeterminate, yeah, non-deterministic. But we'll maybe return to this in future sessions where we talk about kind of tools like Curate GPT that use not fine tuning but RAG, which is another way of trying to provide the language model with additional knowledge about the domain. But yeah, I think we definitely need more evaluations in that area to kind of like help with these kinds of questions.
Okay, well, if that is the total of all the questions that we have for today, then I'll just say thank you to Chris for an excellent demo workshop. And thanks to everybody for attending today's Obo Academy session.
Thank you
And we'll
very
see you again
much.
next time.
All right. Thanks all. Mm-hmm.